Okay. Okay. Yes, please do that.
さあさあさあ、高雪さん。さあさあさあ。さあさあさあ。さあさあさあ。高雪さん。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあさあさあ。さあ たかゆきさん、さんさん、さんさん、
イエーイ。アマビーさん、Okay, wait. さんさんさん、アリーナさん、さんさんさん、アリーナさん、さんさんさん、さんさん、アリーナさん、さんさんさん、アリーナさん、さんさん、アリーナさん、さんさんさん、さんさんさん、さんさんさん、さんさん、アリーナさん、さんさんさん、さん、さんさんさん、イエーイ。
イエーイ。
アンコール、アンコール、アンコール、アンコール、さんさんさん、たかゆきさん、さんさんさん、
さんさんさん、さんさんさん、たかゆきさん、さんさんさん、さんさんさん。
イエーイ。Thank you. Do you wanna hear it? Okay, just one moment. Okay.
Fogarty, and you can think of me as your friendly guide to the English language, writing, history, rules, and cool stuff. Today, I have a segment about why we don't always pronounce the T's in the middle of words like kitten and mitten. Another segment about the difference between the words sneaked and snuck, and a Familect story about a basketball word. I also have a quick correction.
Why mathematics and science can be more challenging. Focused problem solving in math and science is often more effortful than the focused mode thinking involving language and people. This may be because humans haven't evolved over the millennia to manipulate mathematical ideas. Which are frequently more abstractly encrypted than those of the conventional languages. Obviously, we can still think about math and science. It's just that the abstractness and encryptedness adds a level, sometimes a number of levels of complexity. What do I mean by abstractness? You can point to a real live cow chewing its cud in the pasture and equate it with a letter COW on the page. But you can't point to the real live plus sign that the symbol plus is modeled after. The idea underlying the plus sign is more abstract. By encryptedness, I mean that one symbol can stand for a number of different operations or ideas, just as the multiplication sign symbolizes repeated addition. In our pinball analogy, it's as if the abstractness and encryptedness of the math can make the pinball bumpers a bit stronger. It takes extra practice for the bumpers to harden and the pinball to bounce properly. This is why dealing with procrastination, while important in studying any discipline, is particularly important in math and science. We will be talking more about this later, right?
You might say the engine very high. Instead of saying start your engines with a hard T at the end of start, you might say start your engines. Without getting into too many linguistic details, we do this because it's hard to aspirate certain consonants when they fall at the end of a word. We aspirate the P at the beginning of purse all day long, but we swallow it at the end of stop, like when we say stop your bellowing. We aspirate the T at the beginning of toy.
Related to these difficulties in math and science is another challenge. It's called the Einstein-Lang effect, pronounced Einstein-Lang. In the phenomenon, an idea you already have in mind or your simple initial thought prevents a better idea or solution from being found. Yeah, this is what is happening in a mathematical, right? We saw this in the focused pinball picture, where your initial pinball thought went to the upper part of the brain, but the solution thought patterns was in the lower part of the image. The German word Einstein means mindset. Basically, you can remember Einstein as installing a roadblock because of the way you are initially looking at something. I see. This kind of the long approach is especially easy to do in a science because sometimes your initial intuition about what's happening is misleading. You have to unlearn your erroneous, yes, unlearning, right? You have to unlearn your erroneous or older ideas even while you are learning new ones, right? The Einstein effect is a frequent stumbling block for students. It's not just that sometimes your natural intuitions need to be retrained. It's that sometimes it is tough even figuring out where to begin, as when tackling a homework problem. You bumbled about your thoughts far from the actual solution because the crowded bumpers of the focused mode prevent you from springing to a new place where the solution might be found. Yes. This is precisely why one significant mistake students sometimes make in learning math and science is jumping into water before they learn to swim. In other words, they blindly start working on the homework without reading the textbook, attending lectures, viewing online lessons, or speaking with someone knowledgeable. Yeah, okay, I see. This is a recipe for thinking. Thinking, not floating, thinking. It's like randomly allowing a thought to pop off in the focused mode pinball machine without paying any real attention to where the solution truly lies. Understanding how to obtain real solution is important not only in math and science problem solving, but for life in general. For example, a little research, self-awareness, and even self-experimentation can prevent you from being parted with your money, or even your good health, or on products that come with bogus scientific claims. And just having a little knowledge of the relevant math can help prevent you from defaulting on your mortgage, a situation that can have a major negative impact on your life. Right.
And that accident in turn birthed countless others, from the distinct dialects we hear in New York City and Dallas to the ones we hear in New Orleans and Minneapolis. T-glottalization can sound grating or slangy to some listeners today. But someday it may be the way all of us speak, and by that time, no doubt there will be